Hi, let's learn to balance some equations. We're going to start with something really simple. Let's have a look at aluminium plus oxygen, which gives us aluminium oxide. So when we look at chemical equations like this, on this side we have the reactants, and on this side we have the products. And the aim of balancing equations is that the number of atoms on the reactant side is equal to the number of atoms on the product side. So let's have a look at the reactants. We'll start with aluminium. On this side we have one atom of aluminium, and on the product side we have two. And what we want is for the reactants to be equal to the number of products. So to make the reactants equal, we'll do something simple and we'll just times the aluminium by 2. Now let's have a look at the oxygen. On the reactant side we have 2 oxygen atoms. They're diatomic, so they're bonded together, but there are 2 of them. And on this side we have 3. Now what can I do to make the reactants equal? So I need to have 3 on the reactant side. What I could do, and what would be really simple, is to just times it by 1.5. If I could just 1.5 times 2 would give me 3, and that'd be brilliant. But when you think about it, you can't really have 1.5 atoms. But what we can do is, if we times the entire thing by 2, we can get rid of that 1.5 and make it a whole number. So if we're going to times the entire equation by 2, and I'll just change pens, let's go green. I'm going to have 4 aluminiums plus 1.5 times 2 is 3 O2. Now don't forget, I'm going to times the product, aluminium oxide, by 2 as well. Now remember, you can't add something in between here, because this is in one whole molecule, bonded together, okay? You can't add atoms in between, or else it would change what your product is. So to do this really simple, because don't forget, that's one whole molecule, we can just add a 2 in front of it. So that will have aluminium oxide. And so let's have a look, and let's see if our equation is balanced. I have 4 aluminiums in my reactants, and 2 times 2 is 4. Fantastic. I have 4 aluminiums on this side. Let's have a look at our oxygen. I have 3 times 2, so I have 6 here. I'm just going to put a 4 here, that way we can have a look, make it nice and visual. Oh, what's that for? Okay, so I have 3 times 3 times 2 gives me 6. And on this side, I have 2 times 3 gives me 6. So I have the same number of aluminiums on my reactant side as I do on my product side, same amount of oxygens on my reactants and product side. So there we go, our equation's balanced. Let's try something a little more complicated. In an equation such as this, where you have several atoms, you want to start with the most complicated first, and then move on to the single ones. Now in this case we have oxygen O2 sitting by itself on the on the reactant side, so we'll leave that till last. Seeing as carbon is first there, let's start with the carbons. So on this side I have 2 carbons, and on my reactant side I only have 1. So the easiest way to balance that out, let's put a 2 in front of this carbon dioxide. Now let's have a look, change colours, let's have a look at the hydrogen here. I have 4 hydrogens on this side, and when I go over to the reactant side I only have 2. Again, that's really easy to change. Let's put a 2 in front of that hydrogen. That's going to change it to 4. Now let's have a look at the oxygen now. I have here 2. But don't forget, carbon dioxide, we've put a 2 in front of. So it's 2 times 2, which gives us 4. Same thing has happened to this oxygen that's attached to the hydrogen to make water. I only have 1 here, but I have 2 oxygen molecules. So it's 2 times 1. So that gives us 2. So on this side, I have a total of 6 oxygens. And on this side, I only have 2. So what can I do to balance this 2 out? Times it by 3. Now, let's go through and let's double check. So on this side, carbons, 2. Have a look here. Carbons, 2 times 1 gives me 2. Hydrogens, 4 there. Having a look over here, 2 times 2 gives me 4. Let's have a look at the oxygen. 3 times 2 gives me 6. And over here, 1 times the 2 again gives me 2. And over here, 2 times the 2 gives me 4. So when we add these together, gives me 6. Nice and now let's look at something really complicated. When we have things in parentheses, like here, where we have things in brackets, it can get really complicated on how to balance that. Best thing to do, because we have the sulfate group here, and we have the sulfate group here, what we're going to do is substitute it for another letter. And in this case, let's call it atom X. So let's rewrite this equation with atom X in place. So we have our iron oxide plus H2X. Now don't forget it's SO4 together in the sulfate group, so we don't worry about the 4. With our iron, again, our X, SO4, but here we have the 3, so it's X3 plus H2O. And now we can treat this just like a normal equation that we've practiced before. So let's start with our iron, and in this case we have 2 on this side, and having a look here, we have 2 as well. So that one's nice and easy. Going along to oxygen, we have 3 oxygen here. And going on this side, with the water, we only have 1. So to balance that out, let's put a 3 in front of the water molecule. Purple. Alright, let's have a look at hydrogen. We have 2 hydrogens on this side, and having a look here, we have 3 times 2, which gives us 6. So to balance it out on the other side, let's put a 3. Now let's have a look at the sulfate group. I'll go to red. Okay, so with this X, it's 3 by 1. So on this side we have 3 sulfate groups, or 3 atom X's. And having a look on this side, nice and easy, 3. So we're balanced out. Now let's rewrite this equation how it should look. Go back to black. So we have our iron plus 3 H2SO4 with 2 ions. Oh, sorry. Now even I'm getting confused. Take that out. 2S SO4 3 plus 3 H2O. Fit that in. Okay, the really important thing to remember, see how we have the oxygen here, oxygen here? We do have an oxygen in the sulfate group, but remember, in order to make this clear so that we don't separate this oxygen out, I've substituted it for atom X. Okay, this way you're not going to get confused, because if you put the oxygen in there, you're going to balance it out all wrong, because remember, this sulfate group is one molecule. It comes together, and in this case, because it is on both sides, we treat it as though it's one atom. So let's have a look if we're balanced. 2 ions, 2 ions, 3 oxygens, 3 times 1 3 oxygens, 3 times 2, 6 hydrogens, 3 times 2, 6 hydrogens. SO4, remember, it is 1, so 3 by 1 is 3. And having a look here, here's the parenthesis, 3. Nice and balanced. Now remember, when it comes to chemistry, practice makes perfect. If you need more help in balancing equations, come see me in class. I have great worksheets that can help you practice.